Welcome to this explainer. Today, we're diving straight into something that is absolutely crucial for any business, and honestly just super fascinating: pricing strategy. We're going to unpack a brilliant tool developed by the legendary economist Alfred Marshall. It's called the total outlay method, or sometimes you'll hear it called the total expenditure method. If you've ever wondered how companies figure out the exact perfect price to maximize their revenue, well, you're in the right place. And hey, if you're gearing up for an exam, this is a notorious 4 to 6 mark question, so we're going to break it down step by step. We'll look at the math, the consumer psychology, the whole shebang, so you'll have total comprehension by the end. Okay, let's quickly map out our agenda. First, the total outlay method. Second, unit elastic demand. Third, relatively inelastic demand. Fourth, relatively elastic demand. And finally, number 5, price elasticity and expenditure.
So think about this super common, totally relatable dilemma. If a business lowers its prices, are they going to make more money or less money? Seems like a pretty simple question, right? Well, on one hand, a lower price means less profit per item. But on the other hand, cheaper stuff usually means more people buy it. So which force actually wins out? The answer completely depends on elasticity. To figure out the real financial impact of a price change, we absolutely need a solid way to measure that elasticity. Which brings us to Section 1, the total outlay method. Here is Marshall's golden formula. Total outlay, let's just call it TO, is simply price multiplied by quantity demanded. Think about it like this. It's the total money leaving the consumer's wallet, and at the exact same time, it's the total revenue going into the seller's cash register. Marshall basically realized, look, business owners don't always have time to do complex percentage math to figure out elasticity. So instead, just look at the cash register. We measure elasticity simply by tracking what happens to the total outlay after a price change. Ask yourself, when you drop or raise the price, does the total cash coming in go up, go down, or stay exactly the same? That leaves us with 3 possible mathematical outcomes. Let's jump right into the first outcome in Section 2, unit elastic demand. All right, let's look at this schedule. This is our perfectly balanced baseline. Imagine a product priced at 60 rupees. At that price, people demand 10 units. Price times quantity, 60 times 10, gives us a total outlay of 600 rupees. Okay, now the business decides to drop the price to 50 rupees. It's cheaper, so naturally consumers buy more. The quantity demanded goes up to 12 units. But do the math in that final column. 50 times 12 is exactly 600 rupees. The total outlay is completely frozen. That drop in price was perfectly offset by the proportional jump in sales. When this happens, it's called unit elastic demand, meaning elasticity, or EP, is exactly equal to 1.
Now let's visualize what we just calculated. Take a look at this D3 demand curve. See that smooth, swooping shape? In the economics world, this specific curve is called a rectangular hyperbola. And here's the really cool secret to reading this graph. Any point on this curve creates a rectangle with the axes. The height is the price, and the width is the quantity. Because total outlay is literally just price times quantity, the physical area of that rectangle is the total money spent. So as you slide from point A down to point B on this curve, the rectangle stretches and changes shape, sure, but the total area inside stays exactly the same.
So the big takeaway here is that under unit elastic demand, changing the price doesn't change the total expenditure one bit. The business slashed the price by 10 rupees, probably hoping for a massive revenue spike, but at the end of the day, boom, exactly 600 rupees in the register. Just like before, it is a state of perfect equilibrium.
Moving on to Section 3, relatively inelastic demand. Let's analyze a totally different scenario. This schedule represents a rigid market where consumer habits are just really hard to budge. Again, we start at 60 rupees for 10 units, total outlay, 600 rupees. Now we apply that exact same price cut down to 50 rupees. But because the demand here is inelastic, meaning buyers just aren't that responsive to the discount, the quantity only bumps up a tiny bit, from 10 to 11 units. So let's crunch the numbers. 50 times 11 equals 550 rupees. Ouch. By lowering the price, the business didn't stimulate enough new sales, and they actually dragged their total outlay down. And this graph perfectly captures that exact problem. Look at the D2 demand curve. Notice how much steeper it is compared to the last one? That steepness is the absolute hallmark of inelastic demand. When you look at the rectangles representing the cash register, the original one at point A has a pretty solid large area. But when we drop the price to point B, that new rectangle is visibly narrower and smaller. That missing area, that's lost revenue. The tiny bump in sales was nowhere near enough to make up for the big price cut. The main thing to remember here is the direction. When demand is relatively inelastic, where EP is less than 1, total expenditure moves in the exact same direction as the price change. If the price falls, total outlay falls. And honestly, if a business with inelastic demand raises its prices, its total outlay will actually go up. You see this all the time with necessities like basic food staples, life-saving medicines, or electricity. People have to buy them no matter what, so a discount isn't going to trigger some crazy buying spree. Let's transition to Section 4, relatively elastic demand. Now watch the magic of a highly responsive market. We're back at our baseline. 60 rupees, 10 units, 600 rupees total outlay. We drop the price to 50 rupees again. But this time, consumers are incredibly sensitive to the discount. Maybe it's a luxury item, a vacation package, or a hot brand name going on sale. The quantity demanded shoots all the way up to 13 units. Let's calculate that new outlay. 50 times 13 equals 650 rupees. By making the product just a little cheaper, the business tapped into a tidal wave of latent demand and actually boosted their total cash intake. Let's map this one out to really cement the visual difference. Observe the D1 demand curve here. It's noticeably flatter than the previous ones. A flat demand curve visually screams high elasticity, where EP is greater than 1. Now check out those revenue rectangles. When the price drops from 60 down to 50, moving from point A to point B, that new rectangle stretches way out to the right. The sheer size of that new area instantly and clearly tells you there's been a massive surge in total expenditure. Notice the total directional contrast here compared to the last scenario. When demand is relatively elastic, expenditure moves in the complete opposite direction of the price. The price went down, but the total outlay went up. This is literally the dream scenario for a retailer running a massive discount sale. When they slash prices on Black Friday, they aren't doing it out of the goodness of their hearts. They're betting their demand is highly elastic, and that the sheer volume of new shoppers will more than make up for the slimmer profit margin on each item. Finally, Section 5, price elasticity and expenditure. Let's pull back and look at the macro picture. This summary matrix right here is basically a definitive cheat sheet for Marshall's total outlay method. It brilliantly ties together exactly how total expenditure, or TE, tracks consumer responsiveness across any pricing scenario. If elasticity is unitary, EP equals 1, changing your price does absolutely nothing to your total expenditure. It stays constant. If your goods are relatively inelastic, EP is less than 1, price and expenditure are locked together. Lower the price, expenditure falls, raise it, expenditure rises. And if your goods are relatively elastic, EP is greater than 1, price and expenditure act like a seesaw. Drop the price, total expenditure goes up, raise the price, it goes down. Honestly, if you're using this explainer to prep for a test, internalize this exact matrix. It is your ticket to full marks. As we wrap up this explainer, I really want you to think about the everyday things you buy, from your morning coffee to your smartphone. When those brands change their prices, what do? Do you keep buying the exact same amount? Do you cut back completely? Or do you stock up? Your personal elasticity of demand, multiplied by millions of other people, literally controls the pricing power of the brands you love. Marshall's total outlay method isn't just some dusty economic theory. It's the invisible math driving every single price tag you see. Thanks so much for joining me for this deep dive into pricing strategy, and I hope this completely changes how you look at the economics of your daily life.